Hello students, good morning. Welcome to my YouTube channel here. In this class, previously three in three videos we discussed about the dipole basic concept and definition and terms related to dipole. And next two videos we derived two equations that is based on dipole. That is one at axial position and other is at equatorial position. So this is the third expression we are going to derive here. That is electric field, electric field, electric field intensity, electric field intensity at any point, at any point, at any point due to due to electric dipole, due to electric dipole, due to electric dipole. Okay. So now to get this equation we must be perfect in the previous two cases, that is axial position equation and Brodon, that is equatorial position equation. Both we must be remembered for this case because we are considering here two cases. Okay, and see here in figure I drawn that figure, whatever we need to derive this equation I drawn here. So here A and B is a dipole of charge negative q and positive q. They are in opposite in polarity but same in magnitude, same in magnitude here. Okay, so so here dipole moment direction is negative to positive, negative charge to positive charge. Okay, and this dipole moment is making and here. So for this dipole we are taking one point at any point. Okay, not axial and not equatorial. We are taking that point here, this point, and line joining this, the distance of this point is from the center of dipole is x. Okay, center of x is that is distance of that point from the center of dipole is x. And here dipole moment direction making one angle with that line joining that point to center of dipole, that is theta. And here that dipole moment is resolved into two component. According to the vector concept, it is resolved into two component. One is along this line, that we can say is a horizontal component. Okay, I am writing here, and this one is what, perpendicular component. Okay beta. Oh, see here I am explaining this figure. Here AB is what, A and B is a dipole. A and B is a dipole of charge negative q and positive q respectively. And P is a what, dipole moment, dipole moment, dipole moment, dipole moment. Here that line, and that is a dipole moment is making one angle, making angle theta, theta with the line OP, with the line OP. So so dipole moment is resolved into two component, two components. Okay, that is one component is, that is P vector cos theta, which is known as what? Horizontal component. Horizontal component. Horizontal component of dipole moment P vector. And P sin theta is a vertical component. Vertical component of dipole moment P vector. Okay. So this is a small description about this figure. Now, as P is point P is as point P is in axial position, okay, with respect to that is a horizontal component, with respect to P cos theta. Therefore electric field, okay, therefore what? Therefore electric field E1 is what? Electric field intensity. Electric field intensity at P is what? P equal to P1, sorry, E1 equal to what? E1 equal to, according to that axial derivation. Axial derivation is what? That is 2P. This is a component of vector, that is a dipole moment. Okay, so that is 4 pi epsilon naught r cube. So this equation for short dipole, okay, short dipole, it is for and this direction is E1 direction is along PD. It is along P axial line, axially away from the dipole. Okay, axially away from the dipole. Axially away from the dipole. Similarly, E2 is E2 is E2. Similarly, uh, P is axial. Equatorial. P is at equatorial position with respect to what? P sin theta, that is component of dipole moment P. Okay, so therefore electric field E2, okay, E2 is what? P with respect to which one, beta? Which one? With respect to okay, with respect to that is a P sin theta vector divided by 4 pi epsilon naught and r cube, and its direction is along PC, in this direction. Okay, so now E1 E2 both are vector quantity. E1 E2 both are vector quantity, so they are along the adjacent of two two sides of the two adjacent sides of the rectangular. So therefore, a resultant of these two will be along the diagonal of this rectangle, that is PCED. PCED. Therefore we can write here. Therefore, resultant. Therefore, resultant of E1 and E2 is given by what? That is E equal to under square root according to vector addition. Okay, according to vector addition, that is E1 square plus E2 square, and here remaining term becoming constant, that is 2 E1 E2 cos theta becoming what? 0, because angle between E1 and E2 is 90 degree. E1 E2 is 90 degree here. So therefore, since theta is what? Oh, sorry, angle. That since angle between E1 and E2 is 90 degree. 90 degree. So therefore, this term becomes, that is 2 E1 E2 cos 90 equal to 0. So remaining is what? Only these two terms will be there in square root. Therefore E equal to whatever their values are there, E1 and E2, substitute here. That E1 is what? E1 is 2 P cos theta divided by 4 pi epsilon naught r cube whole square, and E2 value is what? This one, that is P, right, in vector, P sin theta divided by 4 pi epsilon naught r cube. Okay. Now, what are the terms constant, that is a common, or they take outside? That is P is common, P, and denominator both the terms are common, that is 4 pi epsilon naught r cube, because square is there, no, square root get cancels, so common term will be as it is. So in bracket, in square, sorry, it's not in bracket, in the square root, that is a 2 square 4 cos square theta plus sin square theta. So now by using some trigonometrical manipulation, we can write this like this, that is P divided by 4 pi r cube, in bracket you write 3, instead of writing 4 cos theta, I am writing here 3 cos square theta. Okay, 3 cos square theta, and once cos square taking this side, cos square theta plus sin square theta, this bracket terms becomes 1. This term becomes 1, that is right here, that is sin square theta plus cos square theta equal to 1, that is according to the trigonometrical identities. Okay, so that equation becomes I'll write here, because of less space, I have to remove this simultaneously. So therefore that equation becomes, that is E equal to P divided by 4 pi epsilon naught r cube, in bracket, and bracket we can write, okay, that bracket we can write, in bracket 3 cos square theta plus 1 to the power 1 by 2, this is the final expression for electric field at any point due to the dipole. and here some by taking that what, by taking here that theta value 1 once 0, by taking 0 this becomes 4. Okay, 4 square root of 4 is 2. Okay, when theta is what, when theta is what, cases are there, some cases when theta equal to 0, theta equal to 0 degree means what, so this e equal to, it becomes e equal to p 4 by epsilon naught r cube, in bracket this becomes 2. Okay, 2 beta. Okay, so therefore 2 2 get cancels, so here, otherwise you can write like this only. Okay, and when theta is 90 degree, 0 degree means what, this e1 e2 along the same line, e1 e2 are the same line, so that time equation becomes this one. When 90 degree, when theta equal to 90 degree, that time this bracket terms, this term becomes 0. Okay, it will be only 1, so that for therefore e equal to p divided by 4 pi epsilon naught r cube. Okay, this is for 90 when both are perpendicular to each other, and here, and this resultant making one angle, that is alpha, therefore tan alpha equal to, tan alpha equal to opposite by, that is de divided by uh, de divided by pd. So this d is what, e2, and e is what, e1, and write their values, and their values are here. First one is e2, e2 is what e2 is, that is p sin theta divided by 4 pi epsilon naught r cube, and e2 e1, no, okay, opposite, this is e1 beta. Okay, this is e1 value is take inverse, this becomes, this is common, 4 pi epsilon naught r cube common, and here 2p cos theta, therefore this p cancels, this term cancels, so there will be only that is 1 by 2, 1 by 2 sin by cos is what, tan theta, tan theta, that is the relation between this theta and alpha, theta and alpha. Okay, so now this is a finally conclude, we can conclude by writing one conclusion. That conclusion is what, that conclusion is, that conclusion is electric field pattern, electric field pattern. So whenever we draw the geometrical figure for electric field for the dipole, we are getting that is cylindrical form, cylindrically symmetrical means what, if this is a dipole, one side means it is a positive, means what, this side, all direction it is in cylindrical form. Okay, cylindrically uh, symmetry. Okay, and for negative also same, but direction is opposite, direction of the radius is opposite, but for point charge, for point charge it is in spherical form, it is in spherical pattern better. Okay, thank you.